Good people, Sanbonad. Today we are doing this video. Remember, this is a reaction video. It's not a memorandum. I will not be answering any question. I'll be just highlighting some few questions, some few tips, some few thoughts that I think it's very important in that specific questions. To those trick questions that need some deep thinking, I would say that probably here needs some little bit of thinking on it. Just a reaction question. Yeah, it's not a memorandum, just a disclaimer there. So yeah, let's get into it, guys. So in question one, which is the structure of the paper, usually start with the statistics, and here they giving you that statement that is there, and also they give you the table. In terms of this table, we have the weights in kg in terms of x, and we have the number of push-ups per minute in terms of y, and then they give us the scatter plot. Now, it's very important to understand the scatter plot because in terms of answering whatever questions that we're gonna answer there, it's very important in terms of the scatter plot. And we're not answering any questions, we're just analyzing the question. 1.1, determine the equation of the least regression line of this data. Again, how do you determine that? You punch those weight in kgs, number of push-ups, in minutes in terms of y in your calculator, you will get your value of a again. In answer, very you get your value of a, you write it down. You get your value of b, you write it down, and then you write it also in terms of a plus bx, and then you substitute the values of a in order for you to get the whole 3 marks. That's how you do that one. And write down the correlation of the coefficient, meaning getting the r. Also you are get it in your calculator because you have put it all this information and all this information in your calculator. That's how you get that value of r. So the first three, these 4 marks, hopefully people did get these 4 marks. And the coach uses the least regression line to set the target of the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that the member of the team who has 20 kg. Again, you have your line, regression line here. In terms of regression line, we know that the weights in terms of my table, I know the weight is terms of x, so it's x. So you take 29, you substitute it in your equation, you get y. What is the y? Y is the number of push-ups. And the question say should do meet the target in terms of what predict the number of push-ups, meaning here you take your 39, your 29, you substitute into your regression line part of value, and then you get these 2 marks. That's how you get the 2 marks. And 1.4, they're saying write down the mean number of push-ups for a data given. So here in the data given, push-ups meaning push-ups where is a push-ups, you get the mean of this data on the data that you've put it in your calculator. This one is y, so you get your y bar. The y bar is your mean. Hopefully you know how to get your your y bar and the mean. That is very also very important. Now, here on 1.5, they're saying the number of train hard during the season. At the end of each season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does the increase of the push-up influence the standard deviation of the data? That is very important question. You need to know in terms of the standard deviation. How does the changing of data influence the standard deviation, which is again very important there. And 1.6, they're saying at the beginning of the season, the coach uses the least regression line as the minimum target for players to aim for, and then determine the maximum possible increase in the number of push-ups that the team member must obtain to reach the minimum target. Oh, okay. See this question, according to what I said, again, I even analyze it more. It's not a memorandum. What I'm going to say may not be saying it's a right answer or the wrong answer in it, but the understanding of these words maximum, minimum are very important based on this question. And also, they're saying at the beginning the coach used the least regression line, which was happening here. So I think this question is based what we did here in 1.1, which probably this was a thinking question, which these 2 marks probably more or less some of us will get it, some of us will not get it. Also this 1 mark. I think some of us will, some of us will not get it. Yeah, that's what there's the reaction. Remember, this is a reaction video. And 1.2, sorry, question 2, the cumulative frequency or the ogive. Now, they didn't give us the table, already gave us the ogive, meaning some of us, I know some of us usually want to draw the ogive. Some of us doesn't want to draw the ogive. But in this case, they did draw us the ogive. And yeah, we need to take information based on whatever, based on the graph gave us in terms of the ogive. Now here, 2.1, estimate the median travel per time. Now again, what's the median? The median, we know it's the middle one. So from here I know I have 60 employees. So from here in 60, I know we say 60, you divide it by 2. The half of 60 is 30. So you come here into 30. Remember, we are looking for the travel in time. So from here, you say dot 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 dot, and then you come here down t t t t t t t t t, and then you estimate. Again, they say estimate, so it's a matter of estimation here. Is it 65, 66, 67, or somewhere there? It's a matter of estimation. How much do you estimate there? And they're also saying estimates the lower quartile, meaning the lower quartile from 30 here. We need to get the mean of here, meaning another mean of here, which is my lower quartile. Now 30 divided by 2 again is going to be 15. Now from 15, you say and then from here you go down. Again, you estimate it's going to be 41, 42, somewhere here, 42, 43 is a matter of estimation. Again, the estimation needs to be more or less around 40s, 41, 40, not 41, is it 42, 43, 44, somewhere there. And again, they're saying we must estimate the interquartile range. Again, interquartile range, how do we get that? Interquartile range is Q3 minus Q1, meaning the upper quartile range, meaning sorry man, the upper quartile minus the lower quartile in order for us to get an interquartile range. Meaning we do have this one here that you found here. We need to find this one that is somewhere here in order for us to say this one minus this one to get the interquartile range. That's how you get these 2 marks. Hopefully we did get these 4 marks that is coming from those first 3 questions. And the minimum and the maximum times taken from the employees to travel to work are 5 and 120 minutes respectively on the scale line in the answer book. Draw a box and a whiskey to indicate the distribution data of this ogive. Okay, now the ogive it's based on what it was happening here. So the ogive is going to be here, which is this is going to be my lower quartile, and my median is going to be this one. Obviously, my maximum it's going to be this one here, and my minimum obviously is going to start here from 0. So the only thing that I don't have according to here, which you already found here, which is my upper quartile, which is going to be 40, which I'm not mistaken, yes, which is gonna come from here and then going down, and then which is gonna be here. So my Bosk and a whisker diagram that they are looking for here. Hey, sorry, that is not supposed to be like that there. That's my Bosk and a whisker diagram. This one not supposed to be like this. So it's supposed to be just here and like this. This is the Bosk and a whisker that they want based on the ogive. That's how it is there. And 2.5, they're saying a company manager indicates that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage will the employees be allowed to? Okay, now here I think the manager indicated all employees need to travel from home an hour or more will be allowed to. Okay, you need to get first thing the people that work an hour or more, and then from that hour or more, you get the percentage out of those employees. You need to get first how many employees that work an hour or more. Then you divide by the total and then you times it by 100. That's how you get this one. We're not gonna get there. First thing that is very important that I'm highlighting, you need to get the people who work an hour or more, you divide it by the total, and then you times it by 100. And 2.6, they're saying employees work 8 hours in the normal day, in the normal working day. The manager decide on the following rules for time to work from home. Okay, and employees is allowed to work in half an hour from home for each time interval for 20 minutes or parts therefore above an hour taken to travel at home. Okay, now this is an analysis question, which is if I can analyze it now, it's gonna waste time and it's gonna make this video very, very long. So hopefully what was needed to be done here, a certain day an employees take 100 time to travel, calculate the number of minutes that the employee will be allowed to work or allowed to work from home on this day. Yeah, that's the thinking question part of this question too. I'm not gonna say more on that because it's gonna waste a lot of time based on this video. Yeah, let's just move on. Question 3, analytical geometry. Okay, DC. Okay, DC, we have 2 points, D and C. You find the gradient y2 minus y1, x2 minus x1. That's how you find the gradient. And you calculate the equation of a DC. Calculation of a DC, you have a gradient. You take 1 point. It's either you take this point or you take this point, wherever point, you get the equation. So I hope everyone got these 2 marks and everyone got these 2 marks. And okay, that is that. Okay, we do have an equation, but remember this point of UB, it's on that line of K. We do have the X of that point. We're needing K, okay, which is the Y, and then you substitute the Y on this equation. Every one of us need to get the -6, which is now these marks will also get, you also have that marks. And then calculating the length of DC, the DC, the length equation, every one of us also need to get these 2 marks. Yeah, these first, how many question? One, two, three, four. Four question was the easy marks. Hopefully it was for all of us. And then 3.5, calculate the ratio of UDB and UDC. Now again, now here we do have this length which is here. So calculation the ratio, we're gonna need the length of UDB. Where is DB? Now it's gonna be UDB. So you need already you have K as -6. So you find the length of Bani UDB and then you just calculate the ratio. After that, you just say DB over DC is equals to whatever length you got under UDB all over whatever length that you found over UDC. That's how we calculate the ratio. Hopefully also we did get these 2 marks there. Now If M is a midpoint at AD, where is AD? Okay, AD somewhere here we have a midpoint, and such as that AC is parallel to MB. So this is M, so this is connected like this. And then calculate that. Now, this one here, it has to do with, again, that's how the beauty of maths comes into play. Because what is going to happen here, it has to do with the proportionality theorem. That is very, very important because now this one is parallel to this one. Now, proportionality and the theorem that we need to know in terms of the proportionality has to come into play in order for us to calculate these ratios that are happening there. Very, very important. Again, it's given, it's further given that the gradient of AD now, AD, it's -4, and the length of AD, the length of AD is this. Calculate, guys, simultaneous equation needs to come into play now. We have on the same like line, we have a gradient on the same line again. We have the length of AD. That simultaneous equation, it has to play here. Hopefully, we did find that coordinate of a using simultaneously, because like from the question, it's telling me that simultaneous needs to happen because both of these things are on the same line. Now, simultaneously here, based on question 4, which is this cycle question, cycle 1, calculating the coordinate of, okay, first read this diagram. In the diagram below, M, which is the center, have this coordinate, and the cycle cuts at the x-axis at N. Okay, at N, where is N? Okay, at N here, yes. And then ST is a tangent. Okay, ST is a tangent to the cycle P at this coordinate, and with R is D maps to 1, where D is greater than 0, meaning D, okay, we know that D obviously cannot be negative. That's why it says greater than 0. And L lies on the cycle, and then, yeah. Okay, it's very, very important. Now calculate the length, write down the coordinates of L. Coordinate of L, we have this as a midpoint. I'm having this using the midpoint formula, or the midpoint of how calculating the midpoint to get this L. That's how you use it. X of M is equals to OX of OP plus the X of OL all over O2. You get same thing as the Y. Use the same thing here. 4.2, hopefully we did get these marks there from calculating the coordinate of L. Now 4.2, determine the equation of ST. The equation of ST now, again, very, very important. They're saying this is a tangent, and we know this is what? This is the diameter. Now, including geometry needs to come into play. Tangent, diameter. This thing tells us this is tangent, perpendicular, radius, meaning this one is perpendicular to that, meaning you need to find the gradient of this one. So the gradient of this one times the gradient of this one, we know now. The gradient of OST times the gradient of, let me say, OMP is needs to give us what? -1. Then the gradient, obviously, that we're gonna get, we got get the gradient of MP from these two coordinates, and then find the gradient of ST from this, and then we're gonna get the gradient of ST, which is, after that we do have a point of P, and then we get the equation from there. Now show that the equation of the cycle, it's that. Now this one, in order for us to come here, we must start to the normal way of knowing x is equals to a squared plus y is equals to, or minus b squared is equals to r squared. We need to start here in order for us to reach in this point, because we do have this one, we do have this one, and also we do have a point in our cycle in order for us to get to r, and then from there you multiply all this in order for us to get this point. That's how we need to get there. Show D it's 7. Where is D? D it's 7. Okay, showing D that it's 7, you do have the equation of a circle. And what are we wanting? We're wanting x, so we do have y. You're gonna find y that way. Calculating the size, meaning the angle of L. Now, calculating the angle of L, again, now, including geometry, needs to come into play. Again, we know this whole angle is 90 degrees, and also we know this whole angle there is 90 degrees because angle at the semicircle. So we do have this one, we do have this one, we don't have this one, but we do have that one, which is the angle in a semicircle. Then thinking has to come into play in order for us. How can we get this one? Because this is, remember, this is a tangent and this is a circle. And then tan chord theorem needs to come into play. Again, very, very important there. Now TR, where is TR? So TR, okay, they're saying TR there. TR is a tangent to the circle at R. Prove that PT. So is it PT is perpendicular to what? To RT. So proving that this one is 90 degrees. How do we prove that one? Obviously, we do have the gradient of this line because we do have an equation of this line. Now we need to find the gradient of this line. Then the gradient of this line times the gradient of that line, if it gives us 90 degrees, and then those two things, they are what? They are perpendicular. Yes. Again, what I need to highlight here, from there, you see, if this thing is perpendicular there, if I can find the gradient of from the line of UM R. Again, if you didn't get R, but we know that R is 7. So if I can get the gradient of this one, I know the gradient of this one times this one because they tell me that RT is a tangent. It's very important. So if this is a tangent, I know that this one and this one, they are perpendicular because tan perpendicular radius. So also, again, from there, getting this one, I know that one and that one, tan perpendicular radius, then yeah, it has to. It has to. Hopefully, you're getting the point that I'm driving here. Now, question 5 is that diagram OP. Okay. What is very important is that finding what is happening here. So x is -3, y it's -4. So we need to find r. Okay, you find r using your Pythagoras theorem. You find your r, and then all these questions are going to be based on what is happening here. Double angle here, you do your double angle based on the 3 double angles that cos have, and then you substitute your values. And here, compound angle is very, very important because it's giving that sine is this based on what is happening here. So compound angle is going to be very, very important also in this specific question that is happening here. If cos is this, now again, this here is very, very important also for us to go into Pythagoras theorem, because this p is going to be over 1, and then you know cos is adjacent over hypotenuse. So if it's adjacent over hypotenuse, you're gonna get your opposite side of cos in order for us to answer this question. Again, this question here, it's gonna be very, very important in order for us to use a compound of cos and a compound of sine. Again, very, very important there. And question 6 now, giving the identity of a cause. Now remember, this identity that they gave us here, they use the compound angle in order for us to do what we did, what they did here, in order for us to come up into this conclusion that they did here. So we need to use this in order for us to solve or to prove this. So what they have here, based on this here, based on the question, because the question is saying use the compound angle or compound angle identity given above to derive the formula of this. So what is happening here? I know that cos of x in this case minus into minus y. Now from here, because this the minus that is very important here. So from here and here, you do whatever that they did here based on this negative sign, and then we're gonna come into this because negative times negative give me a positive. That's what needed to happen here. Then you're gonna use this based on this, taking in mind that this white's negative. Then from there you're done. Now simplifying this, very very important, cos 90 changes the everything, sign of a negative angle. 180 plus, we know 180 plus, it's on that quadrant, and cos is negative on that third quadrant. Yeah, compound angle is also underneath here. It's gonna come into play. 360 plus, first quadrant, everything is positive. 360 minus, 360 minus, it's on the fourth quadrant, and sign is negative on the fourth quadrant. So everything needs to be happening like that there. Hopefully we are on the same page there. Solve for x, giving this. So you take 2, you substitute it here, and then solving for s, obviously you're gonna have to square both sides there. After squaring the both sides, this and this changes because these are the core functions. Hopefully you're gonna manage to solve what was happening there. Calculating the maximum of g, maximum here, again, very very important, this word. I hope you do understand what does this word mean, because in order for us to understand here, the word maximum is very very important. So in this question, hopefully you're gonna get this, and also getting this. So here, the understanding of this word is very, very important. So write down the smallest possible value of x of g will have the maximum interval. Again, having this word maximum again, it's very, very important. Based on the calculus again, this maximum word. And then question 7, write down the equation of the asymptote. You see this thing asymptote and writing down the equation of it. If you know how to, and then they give us the restriction. So the asymptote that we need to write is from here to here. I hope you people can see where is the asymptote. It's even written for us in terms of the dotted lines. So everyone got that one mark. I believe and I think so. Okay. Now write down the values of x in the interval of these, the values of x now from negative here, from negative 180 to 0. Now we're writing the interval where my f at x is less than 0, meaning my f at x below x values. Now from here to here, where is this below? It's below from here going down. That's where it's below. So it's from here to here. That's where it's below. Again, here it's not gonna touch because it's not gonna be equals to. So your answer is from here to here, but I'm not gonna write an answer for you, but it's there. Yeah, 7.3, it's saying grx, it's cos of 2x plus 1. Cos of 2x plus 1. Okay, writing down the period. Now it's very important of again this 2 here. What does this 2 tell us in terms of the period? What is the normal period of a course graph is 360. And then 360, the very important thing is that 2 of you coming into a conclusion in terms of what is the period of the course graph. Again, now here, drawing the graph, you just use a calculator. Hopefully people know how to draw a graph using their calculators. And general solution, okay, very, very important. You need to know how to use to do a general solution. There's nothing much I can say about the general solution. Um, in a diagram below, or in a diagram C, okay, where is C? C is here. Is the foot of the vertical building at D, where is D, is D, and is on the top of the same building, the height of the building. And then CD, okay, CD is 16 meters squared. This 16 is for the distance of CD two observers are standing at 19 meters. So observer of B and observer of A, they are apart in terms of 19 meters apart at point A and B, where A, B, and C lies on the same horizontal plane. Okay, a painter is working at point E, so the painter is there at E on the building, and the angle of elevation of D from A is this, so it's 46,85, and with DEB it's 122. Where is D? Okay, this one here. Okay, and UBCA is that. Where is this one here? Okay, now calculating the length of AC, the distance between the observer A and the foot of the building, meaning calculating the length of AC. So calculating the length of AC, this one, we do have the angle which is opposite to this whole length here of UCD, and we are looking for this. Why we're looking for the adjacent side, which is UAC. So we do have the opposite side and we do have the angle. So it's opposite over adjacent. You use the trig ratio in order for us to get to AC. Hopefully you're on the same page there. And then 8.2 calculates how far from the painter E will the building, how far from the painter at E is from it's from the top of the building, meaning from here. That's what we are looking for according to this specific question, calculating from the pointer E to the top of the building, meaning we're looking for ED. So calculating ED, obviously I do know CD. I need to get this one, EC. Now it's very important. How do I come into this point of finding C? How do I get to that point? I think we must first come in this point here. If possible, that I can find this one here. After finding this one, hopefully I will have to find this one in order for me to find this one. That's where I think the question needs to drive you, because it's no way that I can just go straight to this one without vying somewhere in order for me to reach that point. Now coming here, on a diagram below, A, B, C, D, the cyclic quad. Cyclic quad properties of a cyclic quad are very, very important. And OBC is produced at E and AC is drawn. And then they give me this very important information here, which is this first thing here. It's telling me that according to this, 2A1 is equals to OB. That's what this is telling me. According to this half, that's what this is telling me. Hopefully people did see it. And yeah, and then A2 is 46, C1 is 86. Okay, it's fine there. And calculate the reason with uh calculate with reasons the value of A1. What is A1? So A1, it's here again. This and that properties of a cyclic quad, and then you get to A1 by saying this and that, and then you get A1 there. Hence, prove AD. Where is AD? AD and DC. DC. Proving that, we know that I need to prove that this angle here is going to be equal to that angle here. I'm not going to say much there, but that's what you are supposed to prove there. Okay, theorem, proportionality theorem. There's nothing much to say here. Everyone needs to know how to prove. It's either you prove this theorem or similarity theorem. You need to know how to prove those theorems. Hopefully, people did prove the theorem. Question 10. In a diagram, O is a center. O is a center. Okay. If O is a center, we know that this line now the diameter. Then this one is 90 degrees. Okay. And then OR is perpendicular to PS. Okay. If also this one is 90 degrees. Again, this thing is very important. If this is 90 and then also this is 90, what shape is this thing forming? without even just analyzing the question. Just analyzing the question. You see if this 90 parallel, because this they forming some corresponding whatnot thinking, which is very, very important again, guys, in terms of analyzing the questions based on Euclidean geometry. Very, very important. And then OV, where is OV? OV, it's one, and then OT. So OT, it what? It's four. Now, these are the ratios. So we need to prove that OR, where is OR? OR is what? Is 1 into WS, wait, WS is what? Is 5. So going there, we need to start by what I just did here based on knowing that this and this parallel, and then we need to start by that and that. And then from there, we know from getting that, yeah, it's all about the procedure of doing all these things that I just did. And the length is just gonna come from proving all these proportionality theorems that we just did here in terms of us proving what we're doing here. But yeah, it is a tricky one, but it's not that tricky question. So this one here, question 11, um, in a diagram, A, B, G, F lies on the larger circle. Okay, we have two circles. We have a larger one, smaller one, and E, A, it's a common tangent. Okay, EA, it's common. It's tangented on a small circle, on a bigger circle, and EBCF is a tangent also on the small circle at C. So where is this one? Oh, this one is also a tangent of this small circle. Oh, okay. Judging from the same point, yeah, I'm not gonna say much on this question, but there are a lot of grade level theorem that's gonna have to come into play again on these specific questions. So everything that is gonna be based on these 6 marks here. So which is where is EAG? EA is G. So this one here, it's going to be X. So proving the other angle that is going to be X is going to be based on Ukrait-Levin theorem, some tan chord theorem that's going to have to come into play. Yeah. And then here, proving the similarity. Now, you need to find your triangles based on what it's given here in order for you to prove your similarities. And then obviously this one is just simple similarity. They ask you again, A and A is gonna be equal at some point in terms of these triangles here. I'm not gonna draw them. G and B are gonna be equal in some way. Those are the angles that are gonna be equal. And then F and C, again, those are the angles that are going to be equal in some way. I don't know how, but they're going to be equal in whatever way that is there. And then this has to come from the integration of this and the integration of this in order for it to come into play. And also there's something that is very important again here, which I think is you have to do in terms of the proportionality theorem based on how I saw the question that was happening here. Yeah, that was a very, very long and lengthy reflection. Hopefully, I did justice based on this question. Thank you so much, guys. Mark Evano.